Think about the electricity powering your home. It seems simple, but the grid is one of humanity's most complex machines.
For over a century, the power grid was a one-way street. Power flowed from a centralized plant to your home.
But with the rise of solar panels, electric vehicles, and unpredictable weather, that old system is breaking down. The revolutionary solution is the smart grid, a complete overhaul that merges electrical engineering with information technology. This is not just a power line. It's a living, breathing, intelligent network.
This video will demystify the smart grid. From two-way communication to self-healing power lines.
Let's start by defining the old system, the traditional grid. Its key weakness was the lack of communication from the user back to the utility company. Utilities only knew about a power failure when a customer called to report an outage.
This lack of real-time data meant they couldn't predict peak demand or manage sudden drops in supply. Power generation had to constantly match peak demand, leading to wasted energy during off-peak hours.
The smart grid changes everything by implementing two-way communication. Every part of the system, from the generator to your home appliance, can now send data back to the utility. This is enabled by smart meters, replacing the old mechanical analog meters on homes. Smart meters record electricity consumption in real time, often in 15-minute intervals. They send this detailed consumption data wirelessly back to the utility. This real-time data flow is channeled into a centralized energy management system CROD. EMS uses powerful computing and AI to analyze the data, identifying patterns and predicting future needs. This gives the utility unprecedented visibility into the network's health and stress points. The smart grid is crucial for integrating renewable energy, like solar and wind power. Unlike coal plants, renewable sources are highly intermittent. When solar production spikes or wind suddenly drops, the grid must compensate instantly to maintain frequency and stability. The EMS uses its predictive models to know when and where these fluctuations will occur. It can then automatically dispatch stored power from large battery storage systems connected to the grid.
Furthermore, the smart grid allows distributed generation, small-scale power sources like rooftop solar, to feed power back into the system.
Your home is now both a consumer and a producer of electricity, creating a truly decentralized network. The grid must constantly manage this complex, two-way flow of power dynamically. One of the most futuristic features is self-healing technology. When a tree falls on a power line, the old grid experienced a widespread, long-duration blackout. The smart grid uses sensors along the power lines to instantly detect the precise location of the fault. Automated switches and circuit breakers immediately isolate the damaged section of the grid. The rest of the network is then automatically rerouted to maintain power flow to undamaged areas. This reduces massive blackouts to small, localized, and short-lived interruptions. The smart grid also enables demand response programs for consumers. During peak hours, hot summer afternoons, the utility can signal appliances to reduce consumption. Your smart meter can communicate with your smart AC unit or water heater to temporarily lower power usage. Consumers who participate receive financial incentives, shifting usage away from high-stress periods. Because the grid is highly digitalized, cybersecurity is paramount.
Every communication point, the smart meters, the EMS, the substations, is a potential target. The system employs sophisticated encryption and layered security protocols to protect against malicious attacks.
Protecting the grid's digital infrastructure is now as critical as maintaining its physical wires. The implementation of the smart grid requires massive infrastructure upgrades. Old copper lines are being replaced with high-capacity fiber optics for faster data transmission. Thousands of traditional transformers and circuit breakers must be replaced with intelligent, network-aware devices. This upgrade is a generational, multi-trillion-dollar effort worldwide. The data collected by the smart grid is used for predictive maintenance. Instead of waiting for equipment to fail, the system detects anomalies and schedules repairs proactively. This reduces costly downtime and prevents failures before they cause widespread outages. Electric vehicles will soon become crucial nodes in the smart grid. EVs represent a massive source of distributed battery storage capacity. Vehicle-to-grid technology allows the EV to sell power back to the grid during peak demand. This turns the EV into a mobile, dynamic resource for grid stability. The smart grid is the critical infrastructure necessary for a decarbonized future.
It makes clean energy reliable, manages distributed resources, and drives efficiency. It is the complex operating system that makes the energy transition possible globally. The smart grid is the critical infrastructure necessary for a decarbonized future.
It makes intermittent clean energy reliable by balancing supply and demand instantly. It manages distributed resources and drives overall energy efficiency across the network.
It is the complex operating system that makes the global energy transition technically possible.
The future requires grid stability, and the smart grid provides that essential digital intelligence. Let's delve into the data flow. The smart grid generates petabytes of data daily. This data is transmitted through a secure, dedicated communication layer, often leveraging fiber optics and cellular networks. Data analytics identify energy waste, illegal connections, and equipment performance degradation. This comprehensive data picture is processed by advanced metering infrastructure systems. AMI collects, stores, and analyzes the data before feeding it to the EMS. This allows utilities to implement highly granular, time-of-use tariffs. TOU rates charge consumers different prices based on the time of day the energy is consumed. This financial incentive encourages behavioral change, further leveling the load on the grid. The system constantly performs state estimation, an intricate computational process. State estimation calculates the grid's current operational status using all available sensor measurements. It identifies non-measured parameters, such as voltage fluctuations at remote points, for a complete picture. The smart grid also enables microgrids, small, localized, and self-sufficient power networks. Microgrids can disconnect from the main grid during a failure and operate independently.
This provides incredible resilience for critical infrastructure like hospitals, data centers, and military bases.
Laser measurement units are highly advanced sensors deployed across the transmission network. PMUs measure grid conditions thousands of times per second, providing highly synchronized data.
This extremely high-resolution data is used to detect and prevent wide-area disturbances and cascading blackouts.
The biggest long-term economic benefit is loss reduction. The smart grid minimizes technical losses and non-technical losses pre-run. By optimizing voltage levels across the network, energy waste is dramatically reduced.
This leads to massive annual savings and a reduced carbon footprint for the utility.
In conclusion, the smart grid is the Internet of Energy. It is the digital overlay that brings intelligence and interactivity to the physical flow of power. It replaces century-old mechanical systems with real-time digital control.
This is the only way to reliably handle the complexity of renewable and distributed power sources.
The smart grid ensures that electricity remains the stable, reliable foundation of our modern world. It is a necessary evolution to secure our energy future. From two-way communication to self-healing lines, it is engineering at its finest. The next time you flip a light switch, remember the intelligent network managing that power flow. What revolutionary appliance do you think the smart grid will enable next? Share your thoughts.